The use of non-metallic cable, often referred to as NN cable, in terracotta block walls is generally not permitted by the National Electrical Code. There are several reasons for this prohibition. Firstly, terracotta blocks are porous materials. This porosity allows them to absorb moisture from the surrounding environment. When NM cable is installed within these walls, its insulation is susceptible to deterioration due to prolonged exposure to moisture. This deterioration can compromise the safety of the electrical system. Secondly, NM cable lacks a metal sheath. This absence of a protective layer makes it vulnerable to physical damage. Sharp edges within the terracotta block walls or even rodents can easily damage the cable. This damage can lead to short circuits or other hazardous conditions. Given these limitations, alternative wiring methods are recommended for terracotta block walls to ensure a safe and code-compliant electrical installation. One acceptable method is the use of metal-clad cable, often referred to as MC cable. MC cable features a metal sheath that provides a robust protective barrier. This sheath safeguards the conductors within the cable from both moisture and physical damage. This makes it a more suitable choice for installation in terracotta block walls. Another acceptable method is the use of rigid conduit. This conduit can be made of polyvinyl chloride, often referred to as PVC, or metal. Conduit serves as a protective enclosure for the electrical wires. It effectively prevents damage and minimizes moisture absorption, ensuring the longevity and safety of the wiring system. Electrical metallic tubing, often referred to as EMT, is another option to consider. EMT is a thin-walled metal conduit that is commonly used for exposed wiring applications. While it may not offer the same level of protection as rigid conduit, it still provides a significant improvement over NM cable in terms of physical protection. When retrofitting ungrounded wiring in older homes with terracotta block walls, it is crucial to address the lack of grounding to enhance electrical safety. One option is to install a new grounding electrode. This involves driving a ground rod into the earth near the house and connecting it to the electrical panel. This provides a path for fault current to safely return to the source, reducing the risk of electrical shock. Another approach is to use a dedicated grounding conductor. This involves running a separate grounding conductor, typically green or bare copper, from the electrical panel to each outlet and switch. This creates a reliable grounding path throughout the electrical system. Ground fault circuit interrupters, often referred to as GFCIs, are another valuable safety measure. GFCIs protect against electrical shocks by detecting imbalances in the current flow. When an imbalance is detected, the GFCI quickly trips the circuit, cutting off the power and preventing a potentially fatal shock. Before undertaking any electrical work in a home with terracotta block walls, it is essential to consult with a qualified electrician. This electrician should be familiar with the local building codes and regulations. They can assess the specific conditions of the home and recommend the most appropriate wiring methods. It is also crucial to obtain a permit from the local town inspector before starting any electrical work. This ensures that the work is performed in compliance with applicable codes and regulations. When selecting a wiring method, it is important to choose one that meets the requirements of the National Electrical Code, often referred to as the NEC. The NEC provides comprehensive guidelines for safe electrical installations. Ultimately, the goal is to ensure the long-term reliability and safety of the electrical system. A well-designed and properly installed electrical system will provide years of safe and reliable service. It is important to note that the NEC allows for exceptions in certain situations. For example, an NM cable may be permitted if it is run through holes drilled in the terracotta blocks and protected by a non-metallic sleeve. However, even in these cases, it is generally recommended to use a more robust wiring method whenever possible to enhance safety and reliability. To reiterate the points made, firstly, terracotta blocks are porous materials which leads to moisture absorption that can deteriorate non-metallic cable insulation. Secondly, non-metallic cable lacks a metal sheath. This absence of a protective layer makes it vulnerable to physical damage, and lastly, it is important to consult with a qualified electrician who is familiar with the local building codes and regulations. When dealing with older homes, it is important to verify the existing wirings and capacity rating. Ampacity is the current carrying capacity of a conductor, typically measured in amps. Over time, insulation can degrade, reducing the safe ampacity of the wiring. This is especially true in older homes. Before increasing the load on any circuit, it is imperative to ensure that the existing wiring can safely handle the additional current. This may involve consulting with an electrician to perform a load calculation and verify the wiring's ampacity. If the existing wiring is not adequate, it may need to be replaced with a higher ampacity conductor. Another consideration is the grounding system. In older homes, the grounding system may be inadequate or non-existent. A proper grounding system is essential for electrical safety. It provides a path for fault current to safely return to the source, reducing the risk of electrical shock. If the home does not have a proper grounding system, it should be upgraded. This may involve installing a new grounding electrode system, such as a ground rod or ground plate. It may also involve running a grounding conductor to all outlets and fixtures. Surge protection is another important aspect of electrical safety. Surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protection devices, often referred to as SPD, can protect against surges by diverting excess voltage to ground. SPD should be installed at the main electrical panel and at individual outlets where sensitive electronic equipment is used. Arc fault circuit interrupters, often referred to as ASICs, are another important safety device. ASICs protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. ASICs detect arc faults and quickly trip the circuit, cutting off the power and preventing a fire. ASICs are typically required in bedrooms and other areas where people sleep. When installing recessed lighting, it is important to choose fixtures that are rated for use in insulated ceilings. These fixtures are designed to dissipate heat properly, preventing overheating and potential fire hazards. It is also important to follow the manufacturer's instructions carefully when installing recessed lighting. Overcrowding of electrical boxes can also be a safety hazard. Electrical boxes should not be overcrowded with wires. Overcrowding can lead to overheating and potential fire hazards. If an electrical box is overcrowded, it should be replaced with a larger box. When working with electrical wiring, it is essential to use the proper tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. It is also important to wear safety glasses and gloves to protect against electrical shock and other hazards. Before starting any electrical work, it is essential to disconnect the power to the circuit being worked on. This can be done by turning off the circuit breaker at the main electrical panel. It is also a good idea to test the circuit with a voltage tester to ensure that the power is off. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. The NEC is updated every 3 years. It is important to stay up to date on the latest code requirements to ensure that your electrical work is compliant and safe. You can find the NEC at your local library or bookstore, or you can purchase it online. When selecting electrical equipment, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, often referred to as UL, or Electrical Testing Laboratories, often referred to as ETL. Listed products have been tested and certified to meet safety standards. It is also important to choose products that are appropriate for the intended use. For example, outdoor electrical equipment should be rated for use in wet locations. When installing electrical wiring, it is important to follow the NEC guidelines for wire size and ampacity. The wire size should be appropriate for the amount of current that the circuit will carry. The ampacity of the wire should be high enough to handle the maximum current that the circuit will draw. It is also important to use the correct type of wire for the application. For example, NM cable is typically used for interior wiring, while underground feeder, often referred to as UF cable, is used for underground wiring. When making electrical connections, it is important to use the proper connectors and techniques. Wire connectors should be properly sized for the wires being connected. The connection should be tight and secure. Loose or corroded connections can cause overheating and potential fire hazards. When installing electrical boxes, it is important to mount them securely to the wall or ceiling. The boxes should be flush with the finished surface. The boxes should also be properly grounded. When running electrical wiring through walls or ceilings, it is important to protect the wires from damage. This can be done by using conduit or cable staples. The wires should be run in a neat and orderly manner. The wires should not be exposed or dangling. When installing electrical outlets and switches, it is important to follow the manufacturer's instructions carefully. The outlets and switches should be mounted securely to the electrical boxes. The outlets and switches should be properly grounded. When installing lighting fixtures, it is important to choose fixtures that are appropriate for the location. For example, recessed lighting fixtures should be rated for use in insulated ceilings. The fixtures should be installed in accordance with the manufacturer's instructions. When working with electrical wiring, it is important to be aware of the potential hazards. Electrical shock can be fatal. It is important to take the necessary precautions to protect yourself from electrical shock. This includes disconnecting the power to the circuit being worked on, wearing safety glasses and gloves, and using insulated tools. It is also important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. It is important to take the necessary precautions to protect yourself from arc flash. This includes wearing arc-rated clothing and using arc-rated tools. By following these safety guidelines, you can minimize the risk of electrical hazards and ensure that your electrical work is safe and compliant. Table 3.10.16 of the National Electrical Code provides ampacity ratings for conductors based on insulation type and temperature rating. For example, a 14 American wire gauge copper conductor with type THHN insulation, rated for 90 degrees Celsius, has an ampacity of 20 amps. However, this ampacity must be derated if the conductor is installed in an environment with an ambient temperature higher than 30 degrees Celsius, or if there are more than 3 current-carrying conductors in a raceway or cable. NEC Section 310.15b3 provides adjustment factors for ambient temperature, and NEC Section 310.15b3 provides adjustment factors for the number of conductors in a raceway or cable. The grounding electrode conductor size is determined by NEC Table 2.50.66 based on the size of the service entrance conductors. For example, if the service entrance conductors are 2 American wire gauge copper, the grounding electrode conductor must be at least 8 American wire gauge copper. The size of the equipment grounding conductor is determined by NEC Table 2.50.122 based on the rating of the overcurrent protective device. For example, if the overcurrent protective device is rated at 20 amps, the equipment grounding conductor must be at least 12 American wire gauge copper. Ground fault circuit interrupters are required in dwelling units in bathrooms, kitchens, garages, and outdoors, as per NEC Section 2.10.8. Arc fault circuit interrupters are required in dwelling units in bedrooms, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas, as per NEC Section 2.10.12. Smoke detectors are required in dwelling units in each sleeping room and outside each separate sleeping area, as per NEC Section 7.60.41. Carbon monoxide detectors are required in dwelling units in each sleeping room or within 10 feet of each sleeping room, as per local codes and regulations. The minimum size of service entrance conductors for a dwelling unit is determined by NEC Section 2.30.42 based on the calculated load. For example, if the calculated load is 100 amps, the minimum size of service entrance conductors is 4 American wire gauge copper. The minimum size of branch circuit conductors is determined by NEC Section 2.10.19 based on the rating of the overcurrent protective device. For example, if the overcurrent protective device is rated at 20 amps, the minimum size of branch circuit conductors is 12 American wire gauge copper. The maximum number of outlets permitted on a 20 amp branch circuit is determined by NEC section 2.2014 based on the load per outlet. For example, if the load per outlet is 180 volt amps, the maximum number of outlets permitted on a 20 amp branch circuit is 10. The minimum height of receptacles above the floor is determined by NEC section 2.1052, which requires receptacles to be readily accessible. The typical height is 12 inches above the floor. The minimum height of switches above the floor is determined by NEC section 4.48, which requires switches to be readily accessible. The typical height is 48 inches above the floor. The spacing of receptacles in dwelling units is determined by NEC section 2.1052, which requires receptacles to be located so that no point along the wall line is more than 6 feet from a receptacle. The location of smoke detectors in dwelling units is determined by NEC section 7.6041, which requires smoke detectors to be located in each sleeping room and outside each separate sleeping area. The location of carbon monoxide detectors in dwelling units is determined by local codes and regulations, which typically require carbon monoxide detectors to be located in each sleeping room or within 10 feet of each sleeping room. It is crucial to understand that working with electricity can be dangerous and should only be performed by qualified individuals who are familiar with the NEC and local codes. Always disconnect the power before working on any electrical circuit and take the necessary precautions to protect yourself from electrical shock and arc flash.